TCPIP model, Transmission Control Protocol, Internet Protocol Model. What this model means, we'll try to learn it in detail. There are certain words which are going to come. Let me show you a scenario. The scenario is that you are here and your friend is here. Two parts of the globe. You are staying in Delhi and your friend is, say, he's staying at New York. You want to send some letter, or you can say some packet to him. Now, this friend has said, you have very good almonds in your country. Please send me some almonds, right? So go to the market, bring the almonds, and there will be a polythene bag. You'll keep it in there. These are all almonds inside this. Then what you're going to do, you will try to, because it's going long distance, so you'll have some cushion. And over that cushion, you'll have a proper envelope or a box. Then the friend you have, you're going to write the address here. Say, for example, 3322. A name can be Mr. John, Mr. X. So his name is Mr. John. 322 Street, Ford Avenue. I don't know whether really it exists or not. Just an example I'm taking. New York, America, United States of America. And then you give the pin code. So what you have done is, this is the content you have almonds. This is the data, right? This is the data. On that, you had some cushion. You made some frame, etc. And then over it, you have an envelope. That is going to be a packet. We are going to relate everything later. So you want to send him. What you're going to do, you'll hire some agency like Blue Dot. You will give the packet, or say your government agency like India, it's Indian Post Services, Indian Postal Services, and you're going to use their services. You'll give them with proper money you pay. Now this can go to, now if somebody goes there and asks about Mr. John, John will be known because John lives in that society, that community. John will be known. But in India or in any place other than America, who is going to know John? There are multiple number of Johns. So the address, his name is actually physical name, physical address. His name, only those people who are there which knows. So to know him everywhere in the world, we have an address. We have a proper address, so that is logical address. So physical address is the name of this guy. Everyone knows him in the community. But logical address is the address you have given on this envelope. Okay? Now you have done everything. You gave it to the postal services. Now I don't know where it goes. I'm assuming it goes to China, right? China Eastern Airlines they take, and it goes to Guangzhou. And this now, China, it wants to go to, the next flight is going to Frankfurt. So it goes to Frankfurt. And then finally it goes to multiple hops. These are multiple hops, multiple nodes, multiple networks. So every time, every country, every place, the address is being seen and it is directed such that this goes, or that this envelope reaches the person at New York. Now this packet may be lost. It may be possible. You might have seen it. But normally it doesn't. In TCP, it will never be lost. In UDP, it may. So it goes to China or Frankfurt. Take any other city inside or country, city or country, any, because it will go multiple hops. Finally, the person, John, he has a postal services office. They know that this is John and they go, they send, and it reaches there. And this is what is the network means. Computer networks is exactly like this. The communication happening here in the internet when we talk. So whatever packets or information goes from different hops, in what way things are transmitted and received, that is what we are going to see in TCP/IP, especially in terms of inter-network. There's one more scenario before we go ahead. There is an organization, there is a university, just say. Now we have another, now in this place, you are here. This is your computer. Now you just opened a browser like Chrome and you type facebook.com. You didn't even give anything, Facebook you wrote. HTTPS will be added to this fb.com. You don't have to do anything. Now you want that something to communicate, because you want these fb.com pages to come on your desktop, on your computer. So this fb.com is the name, but computer and the nodes in between, they don't know fb.com. They are not worried about that. Going to some other place, say Washington DC, I don't know where fb.com server is, where this server, ISP or says fb.com pages are stored. Now you are here, your university at another end, how to get the pages from there. So this HTTPS is responsible for getting those pages. So this is whole network you have. This is your system, your girlfriend has a system, your brother has a system, these are called host. So network is whole network. Inside this, all the nodes, all the systems, all the gadgets are host. They will be called as host. It may be computer or anything which is IP enabled. These are all hosts inside a network. Now you go to another part of the world. Facebook will also have some network, maybe, and it has. fb.com, as I said, nobody knows. You and me only know. Compute all the digitally known gadgets. They only know 1 and 0. So how to transfer the fb.com or facebook.com? So there is a domain name system which is at the first layer, and this fb.com DNS will take and it will give you the IP address. That is a 32-bit address. It's not an address, it's a number, 1010 formation. Okay, it is actually address, but I want you to understand it to be 10 combination. Now this information goes. Now there can be other network. There can be a subnet also. That is the network inside a network. There can be. So a system not only needs to be known in a network, it also needs to be known inside a network of networks. This is how the communication will work. We'll talk about OSI. We'll talk about TCPIP. The main thing is to get the data, to send the data, maybe fast manner, this UDP, or slow manner, TCP, and reliability. You want to send a document, you want reliability, you want to have a video chat or say audio call. You don't need reliability, you just want faster communication. Okay, so ultimately everyone has to have an address to be known in all the networks of the network on this globe. So there are certain ways, certain things being done, and this network and host, this word is going to come again and again. First of all, start with OSI Reference Model. This is TCPIP conceptual layers. See, it's a reference model. What does it mean, reference? See, ISO OSI stands for, it's International Standardization Organization. So this International Organization for Standardization, the work of this organization is only to make documentation, to make certain thing work. OSI means Open System Interconnection. So whenever two systems, two hosts, they want to communicate, they want to talk, what is the prakriya, what is the way, what are the things needs to be done. So there is a proper way, a documentation, or you see, in your office, a security person is not supposed to go into the administration and make bills for you. He's not going to go and manufacture. He's not going to program. He is a security guy. So every layer, the ISO has decided that every layer has certain special tasks to do. Every responsibility is given to each and every layer. Now, what is the relationship between OSI and TCP? There is good relationship. There is also some non-relationship. Because OSI was a proper way, it's a very formal way where it is being referenced and is being formulated so that everyone on the network, on the communication channel, knows that this layer should do what. Every layer we are going to understand. But the TCP/IP, if you see, it's conceptual layers. OSI reference model there was a committee, people sat together, they built it. Means they form a proper protocols, they wrote everything on the paper. But TCP/IP doesn't start like that. Nobody sat, there was no committee. Department of Defense, United States of America. So they started with ARPANET, they called it DARPANET. And they want to communicate, they want to have a proper way of communicate between different, you can say, those networks or those systems which are incompatible. They wanted to have a way so that everyone can communicate. So they connected their own systems, and there was step by step different protocols were formed. Protocols means two parties are talking, How to talk? What is the way of talking? That is, when you have talked to your father, you give respect. When you talk to your friend, you can be casual. Okay, there is a protocol. You don't wear tie and coat and go to the discotheque, right? So protocol means there are certain ways, certain rules, regulation, niyam kanun, so that these two parties can communicate, talk. So Department of Defense, when this thing were happening, and this goes layer by layer, step by step. Now they have to have a connection with universities also, because university give them knowledge and other things. So the universities also got connected, major universities. Now step by step, other network also started connecting it, and they found this method or this way of communication very elegant, very simple, comfortable to use. So that is how internetworks it was called earlier. Now we call, in short, it's called internet, but it is basically internetworks, communication between different networks. So when this was done, OSI reference model was already there. So when this was being made, people were talking on this internet. So they thought, what kind of layer of OSI meets the layering or a conceptual layering at TCPIP? So everyone, researcher, people, they started talking what layer we should name in this new kind of communication we are having. So they thought, so if you see, there are different books, Frozon book and Tenenbaum books and different books like. So first is OSI has 7 layers, A, P, S, T, and DP, A, P, S, T, and DP. These are 7 layers. But in different books, TCPIP layer, somewhere it is given as 5 layers, somewhere it is given as 4 layers. So what happened was, this application presentation session layer, all these were combined as application layer, transport, network. And data link, physical work together was called as network interface. Now these all name in the TCP/IP I am going to change depending upon the book. So it will change, right? Now TCP/IP protocol suite, every layer, this name is going to change again and again, right? Different books have different way of expressing. TCP/IP protocol suite, where you and me means interact, that is the computer screen. So we do something, we want communication to start or some to get, to upload, to download. Everything is done. All the protocols work here are these. The lowest one, this is layer 1, is data link and physical. You combine them. Physical layer actually previously. Now in the second layer, don't worry about ICMP, IGMP, RARP and ARP. We have to worry about the IP. These all are for support and everything, but IP. In transport, you need to know TCP, UDP, very important. And APS, application presentation session, SMTP, FTP, I'll try to take them very briefly. So all these protocols have some different work. TCP/IP. TCP/IP, I told you the background. TCP/IP, there are 2 protocols, or one is the packet formation, one is the protocol connection oriented protocol, TCP/IP. And these 2 things means, one is the transport layer protocol, one is the internet layer. These 2 are combined and they made a whole model. So TCP/IP model, we need to understand TCP and IP very well. So it was designed and developed by Department of Defense, DoD, in 1960s. And there are standard protocols all over the world. We are using it, and everyone knows what this protocol are going to work. And TCP, transmission control protocol. Transmission means sending, right, or receiving. Controlling also, control protocol. And in internet protocol, we'll talk about that. TCP/IP is, you can call it as a concise version of OSI model. There was no one who wanted to make TCP/IP model. There was no one. It just came into being from a project, from a simple project. It has become to a worldwide accepted model. Okay, every OSI model was a proper made model. TCP/IP has 4 layers. You can call it as 5 layers also. And these are the name I told you in different books, different names are given. So first layer, application, second, transport, third, internet, fourth, link. And you can call it transport as host to host also, link as network access also. Whichever you like, you can name it like that. As I said, every layer has something to add, something to do, some work assigned. I'll start with this, and sending host is me, receiving host is you. Now I want remotely to log in to your system. I want to log in to your system. I want to not log in. So here, whatever system I have command prompt, I have terminal, or whatever things we have. I just wrote, use my hand and type some command. And this host, I told you that this is the destination. I want to log into this system. This was application layer. What happened transport layer? This is packet here. Application layer starts with a packet. And there is no layering. I'm telling you, there is no layering. See, these are layering are defined just because we want every word to be encapsulated such that we know every layer what it does. In transport layer, as I said, application layer has packets. Now TCP layer has TCP segment. At transport layer, it becomes segment. And whatever goes here, whatever is happening on the sender side, reverse is happening at the receiving host. So whatever I wrote, it now at transport layer, it became TCP segment. It became TCP segment. At internet layer, it became datagram. Datagram always, segment are bigger, datagram are smaller. So IP datagram, internet protocol, here IP is coming. So TCP IP, these two are very important. Now data link layer, everywhere some 4 layer, 5 layer are given. So I'll take them simultaneously. At data link layer, it will be frame, and physical layer and data link is why it is combined, because both where it is frames. Actually, here we have bit formation. So network media, I'll start with here. Understand it once again. Bit means what? 1 and 0. Say plus 5 volt, you assign it to be 1, and you have 0 volt, you assign it to be 0. In electronics, this 1 is for on, 0 is for off. 1 is for on, 0 for off. In bit form, because there are 2 bits, 0 is off, 1 is on. So we have, you just count them, 1 and 0 becomes 2. So this is 2, that is why it is binary. That is why this is binary. And this binary, only this 0, 1 is known to every digital gadget. Now this passes through coaxial, copper, fiber. Here actually transmission is taking place in the form of bits. When this bit, when it becomes a frame, what a frame? So we have a proper MAC, this medium access layer, this MAC. MAC is, you just say that it is a number, okay? It has some, from where it is, this company has made, specific number is there, MAC. After that, a packet is being formed. Now this packet, as I said, for packet, as I told you earlier, for almonds, this bit formation is almonds. Then you have some cushion, that is frame. Then you have a packet, and in on that packet you write the address. So destination IP is the actual address. But there are different type of Johns. So you need to know the port also. This happens at segment level. So we have different type of devices. It can be computer, it can be server, it can be some air conditioner. So there is a MAC address. There is a network interface card mostly, or there can be other equivalent things also. And here we run the application. So all these things are dealing with this in one or the other way. To know this computer, you need to know the MAC. To know this computer, you need to know if it is connected to the network, you need to know the IP address. And which service you have to open, for example, HTTP, HTTPS, 80 port you need to know. The port 80 is open or closed depending upon this. Every layer in TCPIP, I want to tell you in brief that physical layer, that is the lowest level layer, when you connect the wires and actual bit stream is passed, if you see that on these 2 ports, you will see that in your computer. So here actual transmission of bit is happening actually, and these are nothing but bits, but they are voltages. They are electricity, you can say. So here the physical layer is the transceiver, transmission receiver. It transmits also, bit is transmitted also, bit is received also. And these are signals, just digital signals, and this pass on the network. Then coming to MAC, data link layer. I'm taking 5 layers. There are 4 layers also. So here data link layer is responsible for creating the frames. Now the MAC, this is transferring of frame with physical MAC addresses. Every system has a proper physical address unique to them. Network layer, what is the word? The network layer is responsible for creating the packets. That is the covering. And as I said, there has to be a logical address, because in order to know a computer on whole globe, you cannot know the perfect number. You need to know the logical address. So transfer packets with virtual IP address. Transport layer, we have TCP and UDP. It establishes, the work of transport layer is to establish the connection between the applications on different hosts. So when we have a connection, it has to have a connection with a remote host. It can be connection TCP, non-connection UDP. Application layer where you are sitting, you and me are sitting. Okay, so we have a system, we have a mobile or whatever, we have a browser, or we have some file transfer thing, FileZilla, and the application layer is the group of application requiring network communication. Now, this will start actually that I want to communicate. I want the web pages of facebook.com to be placed on my system. I want this. So this is application layer. Let us take one layer, one by one. Network access layer. Network access layer, I just change the name, whatever name you are comfortable to use. Network access layer is the layer in the TCPIP model at which the data is transmitted. Actual data in bit form is received and transmitted across the physical network, that is the wires, actual wires. As I said, we have NIC, all the system, NIC or equivalent thing will be there, network interface device, and usually a line card or adapter or a port. So this is used to connect the physical wires or fibers. These are the ports, or you can say these are where actually you put this wire so that actual communication goes. It's a physical wire, it can be fiber, it goes in the form of light in fibers, bit physical wire, so that computers or systems can communicate anywhere from anywhere. And here if you see, this is Ethernet data array. Maximum transmission unit, 1500 byte is maximum. And here Ethernet address is being added, which is 14 byte. Here IP frame is the encapsulation. And for error, this is FCS, checksum. In network access layer, this is, if you correspond or want a correspondence with the OSI model, data link layer and physical layer you combine, and these are going to be this is OSI layer, combine them, and this is network access layer in our TCPIP model. The protocol present in this layer allows the physical transmission. Actual bit value, actual voltages, actual signals are going here. What are the functions? Framing, as I said, adding physical address header to message. We are talking about physical address. I'm talking about an actual address that is known to that system, physically known. We're not talking about logical. We are talking about actual address which is given by the company. And transmission of bits, as I said, whatever connection medium is there, 0, 1, 1, 0, this is going to be transferred or received. Flow control, flow can happen. Flow, 10 Mbps line is there, 2 Mbps line is there. You cannot have compatibility. So you need to break that 10 Mbps into 2 to 2 Mbps. So there has to be a flow control. The speed or the way or different networks needs to be equal. Error control, you may lose. So there has to be error control. Access control, you don't want, say Facebook doesn't want you to enter or don't want you to get the pages. It is access control. Internet layer. So this layer is equivalent to the OSI network layer. TCP/IP internet layer is equivalent to that. It defines the protocol which are responsible for the logical transmission. Physical transmission, actual wires were there, and they are going to actual cards which have actual numbers from the company. Now here it is logical transmission. So if you want to send somebody something, you need to write the actual address so that everyone across the world knows this address. So this is the logical transmission. Here, you have put the bits here, but it has to go in a certain way. That is, here we have to frame the packets. The logical address, which is the address I'm talking about, the IP address of that particular node, host or network needs to be known, which is added to the packets. And routing the word has come from route. So what is the best route? Routing tables are being made, and there are protocols and there are algorithms also, shortest path first, like this. So this routing is basically sending from one place to another. IP frame is here. Now inside this we have IP header. We are adding IP header 20 bytes and IP data array, which is the actual payload, which is actual content which has come from the lower layer. Protocol which we have now, as I said, TCP/IP in IP बहुत important है. IP is very important. So this IP stands for Internet Protocol, and this is responsible for delivering packets from the source host to the destination host. How? By looking at the IP addresses. The IP addresses is having a unique number everywhere. You can find it from anywhere. IP address is a 32-bit address. 4 octets are there. So this IP address is seen by everyone, like the router or anything in between. They see the IP address, they route it in that direction. IP has 2 versions, IPv4, IPv6. IPv4 is all the systems on our websites or whatever name you can give, everything is on IPv4. They are using this. And since it was being made long back, so there is a problem here. IPv6 has come just to overcome that problem. And since nobody has thought that the internet or this kind of thing will extend it so much, IPv4, the thing is, it's a 32-bit address. You take Indian population, it's around 1.3 billion. If you take Chinese population, 1.39, so around, if you add it, it will be around 2.7 billion. Now, assume that everyone has two system IP addresses. Only these two countries will take all the IPv4 address. So 4 billion is possible only from IPv4. If you take 2 to the power 32, it will be 4 billion. So what about others? Every system is coming on the network. So we need to uniquely know them. So we need to have IPv6. IPv6 is a 128-bit address. 2 to the power 128 are the possible number of IP addresses, and it's secure also, and it has various other possibilities. I'll not go into the detail, but you need to know how does an IP datagram looks like. What are the contents? So basically, this A part is the IP datagram, where you have the payload, which is the actual content, badam or almonds, which you have here, and the bits here actually, and then a header is added. Now this header is shown in the below diagram. If you see, payload is the actual content, actual data, actual bits. Header is because if you want to send a IP datagram, everyone should know it, where to send, where to, So for that, we need to have a header. So the two important things are source IP address and destination IP address. These two are very important because this IP address, 32-bit address, unique address is known to everyone. So this header, when the router exam opens this header, it knows, oh, this has to go to this destination. So source also is known, destination is also known. Now the router can send this, or be in between some gateways there, they can send it to the proper destination. Transport layer. And this is similar to, analogous to the transport layer of the OSI model. Transport layer of the OSI model. Now the work is end-to-end communication and also error-free delivery of data. What are the responsibilities? First, you see this is TCP frame, and inside this we have TCP header, TCP data array is the actual content. But here we are also adding port number. In this TCP header, previously I talked about IP. Now I'm adding one more thing to this, port number. This header is 20 bytes. Now the responsibility of transport layers are segmentation and reassembly. What is segmentation reassembly? The first responsibility is this. See, if you have a pizza, now you can't eat it like this. You divide it into triangular or say some form of division so that you can eat it properly. So if you have this much of data and you cannot eat, you cannot send it because of different variety of networks in between. Now you want to send it. When you send it, you can send these slices, but you promised him to send a pizza. You cannot send him the bifurcated ones or segmented one. So at the receiver, it has to be assembled, reassembled. Finally, he has to get a round proper pizza. So this segmentation and reassembly is the responsibility of transport layer. The transport layer divides the data into pieces. And when these pieces are divided, again we have to add a header because header have the all information on the network to know that packet. So whenever we divide into different pieces, this is segmentation. And this segment has to be added with header. And this can be a UDP header. It can be a TCP header. Okay. So these different pieces, it depends on how much pieces you are going to make. And this UDP datagram, generally the UDP size is less. TCP is not that less. And UDP header, because it's not doing much of the work, it is just sending. It has nothing to do with acknowledgement or recovery. So UDP adds just source and destination ports. In TCP segment, TCP does a lot of work. It also has connection. It has to be a connection first. Then if error is there, it will retransmit. And reliability is ensured here. Flow control, congestion is there. That is why if you see the header of TCP has a lot many things inside the header rather than to UDP, which has very less number. I'll show you the headers also. TCP segment or TCP is transmission control protocol, and that is the Merudand, or you can say backbone of the TCPIP model. So we have TCP, all these content are there, which has had to be added to the header. But main thing is in both of these, it's ports we are talking, PORTS. Ports we are talking. Previously we talked about something else. Now here ports. So there are so many things which happens in TCP, and TCP takes care of that also. There is one more responsibility of transport layer is the process to process communication. So what is the process and what kind of data delivery are possible? if you see there is a computer, it can run various processes. Say if something happens to your system, you go to the task manager, you right click and kill the process. You do that. So these are the processes which are running multiple processes. So when a system process connects with the other system process on a network, that is the reliability, that is the responsibility of transport layer. When you have a node or a computer, right, and this second computer, this is host to host delivery, and this is the network layer responsibility. When we have different nodes in between, and there is one hop to hop, this is node to node communication or transmission, and this is the delivery done by, or type of delivery taken care by data link layer. So node to node, data link layer, host to host, network layer, process to process is transport layer. This is the responsibility of transport layer. Now coming to the protocols which are present in transport layer, TCP and UDP, transmission control protocol, and UDP, user datagram protocol. The whole TCPIP, the name has TCP in it. So what is this? You and me are going to talk on phone. We'll decide something. Oh, we need to have a communication. So let's have a proper communication mechanism. I send you something. These are two systems, you and me. So we have I sent you something. You said packet number 1 to 4 has come. You have sent me 4 packets. 3 is not coming, or 3 I didn't get, and I got the information. I'll say, oh, no problem, my dear. I'm going to send you third one also. So this is how TCP works. That is, acknowledgement you get, flow of control is also there, and there are acknowledgement feature, flow control feature. It's a connection oriented protocol. First you have to have a connection, then only things can be done. In user datagram protocol, see, datagram, because the size is less here, the data packets in usergram is like this. So these are two people, you and me. I send something to you, I threw something to you. If you get it, it's okay. If you don't get it, it's also okay. So if you are doing video call, you don't want it to be reliable, you want it to be fast. But you send a mail, you want it to be reliable. These documents, for that we can only use TCP. But when you are doing video chat or audio chat, if some packets are lost, it doesn't matter. So UDP, because it is very fast. Transmission control protocol is low, because if you see Netflix and Amazon Prime, etc., UDP is used here. TCP, it's taking a lot of time, but it's reliable. So this user datagram protocol, as I said, no reliability is ensured. You will never ask me. I will also never ask you. You'll never say you didn't give me that thing. We don't have a connection previously. I just send it to you. If you get it, well. If you don't get it, you will never ask for it. I'll never give it to you. Here are the TCP segment header format and UDP datagram header format. Why I meant to show you is that the content of TCP are more, because it is reliable, it is acknowledging, it is taking care of the errors, it is resending, all these things. That is why we have in this header a lot more information. Along with the ports, two things in your mind: ports, has to be there, port has to be there, and every port it is decided which service will open which port. So TCP has a long header, but UDP you don't need anything, only source port, destination port. So you see there are less content in UDP datagram. Application layer, this is the topmost layer. Application layer performs the function of top 3 layers of OSI: application, presentation, and session layer. And we combine them and we call them as it's an application layer. Here, node to node communication done. I just showed you the type of delivery, the node to node delivery, communication, not delivery, communication actually. So it controls user interface also. So if you sit in front of your computer, you have a chair, you sit here, you click the mouse, you have a browser, you want to have a web page, or you want to upload or download a file, you do some. So that all thing, there has to be some protocols for that. For that we have HTTP, HTTPS, FTP, Telnet, SMTP. You want to send or receive hypertext pages or web pages, hypertext documents. For that you use HTTPS. HTTP plus security or encryption is HTTPS. Now you want to send some file through FileZilla or any other utility, FTP, file transfer protocol, Telnet, SMTP. For mail you have SMTP. So what are the responsibilities of application layer? There are certain encryption, compression, how the message needs to be represented. The application user data or ADU is 1460 bytes maximum. This is what is agreed upon. Encryption means if you are sending something to someone, and if some bad apple is there in between, and he or she wants to take advantage of that, he will not be decrypting that message. These are different. As I said, every service has a port. So application layer protocol, FTP, and there is a type, either it is TCP or UDP, either it is connectionless or connection oriented. So if you have MP3, you want to send it. For that, you'll use FTP, file transfer protocol. So this FileZilla you're using or any other utility, so that, uploading, downloading, so you're using here on the background FTP only. In browser, you are doing something, you are actually working with HTTP protocol. And this HTTP, as I said, the port number will be always 80. HTTP service will have port number 80. Okay, every port is decided, it is clearly defined. Domain name, server or service, it's a service. So it changes the IP to name to IP. So that is 53 number port. 53 number port. 80, as I just said, HTTPS. This is important. 80 is important. So these are application layer protocol. These are what a type of underlying transport layer protocol they use, and which port it is going to open, and what word they do. What telnet, for example, it's an unencrypted login. If you want to log into some remote system. HTTP, as I said, hypertext transfer protocol, passing and giving and taking of what? Web pages. So application layer, as I just said, file transfer protocol. For file transfer, FTP, TFTP network file system is used. When you send Gmail, email, so simple mail transfer protocol is there. For remote login, from here you want to log into some other country's system. For that you have telnet, or login you have. For network management, because there are different network parts, so you have to manage them. SNMP, simple network management protocol. Name management, you have DNS system, like example I said. Name, IP change, vice versa. Domain name system. So these are the different protocols, most of the protocols which use. DHCP is dynamic host configuration protocol. It dynamically assigns the IP addresses. Dynamically. DNS means domain name system. The work is translating the website name to the IP address. IP address is known to the computers, website is known to us. HTTP, hypertext transfer protocol. It is used to transfer and receive and send web pages. NBNS is NetBIOS name services. It translates the local host names to the IP addresses. SMTP is simple mail transfer protocol. It sends email messages like Gmail, Yahoo Mail. SNMP is because there are a number of network devices. This is simple network management protocol to take care of the network devices. SNTP is simple network time protocol. It provides you time of the day. Telnet is a bidirectional text communication via a terminal application. TFTP is trivial file transfer protocol. It is used to transfer very small amounts of data. So this is all about this TCP/IP. Thank you so much. Take care of yourself.